Good morning, everyone. My name is Curt Castagna. I'm the president of NATA, and I'm proud to be here today for this hour-long discussion on transitioning to unleaded fuel and a meeting with some of the key folks in this area that are leading this effort. Curt Castagna, the CEO of Swift Fuels, beautiful picture there, Chris. Robert Olislagers, senior coordinator for the Eagle Initiative, and longtime friend of Southern California for sure, and former director at the Centennial Airport in Colorado. And then Steve Berry from NATA, our managing director of our Safety First programs, who will discuss our vision and how we're managing this transition for our members. So today I'll just be moderating this. We have a slide deck that we're going to go through as kind of an update on Eagle and Chris's program. We have some questions that we'll be asking each other, and we certainly want to hear from those of you that might have questions either through the chat box or raising your hand, and either Steve or I or Jillian on our team will moderate those. So with that, I'd like to just remind everyone how we are in our industry is relative to this commitment. All of the trade organizations, the National Business Aviation Association, NBAA, Aircraft Owners and Pilots Association, AOPA, the General Aviation Manufacturers Association, or GAMA, the Helicopter Association International, NATA, ourselves, and the National Organization of State Officials. All of us are working together on this initiative and have aligned ourselves that we're committed to a transition away from the leaded fuel by 2030. And you'll hear more specifics about that. Just a little bit of industry data to put this in perspective. There's about roughly anywhere from, let's say, 220 to 250,000 piston-powered aircraft in the United States in the fleet. And there's roughly anywhere from 160 to 180 million gallons of 100 low-lead gasoline that is being produced for that fleet annually. To put that in perspective, I think worldwide, the airline industry burns roughly around 94 billion gallons of fuel. And in the US carriers, it's roughly about 35 billion. And in the general aviation, business aviation sector for jet fuel, which we're not talking about today, that's roughly 1.7 billion gallons of jet fuel. So putting that 160 and 180 million gallons in perspective, our focus is really as a group is what is a rational transition that is going to protect the national airspace system and the 220,000 fleet of aircraft so that we do not disrupt that system, nor do we create an unsafe environment. And that's really the focus of what Eagle's doing on the regulatory front with all of these groups. Steve, go to the next slide. So some of the things we'll talk about today are just the complexities in this process, the recipe of the fuel alone, and the 4 different fuel divisions or groups that are out pursuing either STC or a fleet-wide authorization through the original PAFI program that was established by the FAA. And then the whole refinement process and transportation process, what that's going to look like eventually. And then I like to say there's 3 legs to this stool of this transition. There's certainly the approval of the FAA. There's the approval of the engine OEM manufacturers who need to look at the products in their engines relative to issues of warranty and certification of their own. And then there's the ASTM standard, or what I like to say is the universal recipe for the fuel and the importance of that. And that kind of rolls up into the standards of how this fuel and these fuels are going to be managed so that they're delivered to the aircraft safely to eliminate the potential for misfueling. Next, Steve. So I'm going to turn it over to Mr. Olislagers to talk about Eagle and a few slides here, and then we'll transition to Curt Castagna with Robert.
Hey, good morning. Thank you, Curt, for the introduction, and good morning, everyone listening on this webinar. My name is Robert Olislagers. I'm the Senior Coordinator for the Eliminate Aviation Gasoline and Lead Emissions Coalition, very smartly acronym EAGLE, and you can see our logo up there. So I've been in the general aviation industry for nearly 40 years. I manage general aviation airports in New York, California, and Colorado by way of introduction. The mission statement really for Eagle is to eliminate the use of leaded aviation fuel for piston aircraft by the end of this decade without adversely affecting the safe and efficient operation of the general aviation fleet. And we can get into that in a little bit more as to why that safe and efficient transition is really critical to our operations. Curt has already given you some statistics, but general aviation includes really all aircraft except commercial and military. However, general aviation does provide ancillary services to those aviation sectors as well. GA supports recreational flying, firefighting, search and rescue, backcountry medical support, emergency response, and more. Every commercial airline pilot, virtually every commercial airline pilot, and most military pilots actually begin their flight training in general aviation airplanes. I think it's really important to stress that. GA generates some $2.4 billion annually in direct, indirect, and induced economic impact. And that's every year, while supporting nearly 2.1 million jobs in the United States. Homeland Security refers to general aviation as an essential service. However, equally critical to maintaining these jobs and job functions is removing lead from avgas. So enter EAGLE. If we can go to the next slide. EAGLE was formed as an industry government coalition partnership. And this slide shows you the associations representing industry. Chris mentioned all of them already, but it's worth noting that organizations like the American Petroleum Institute, the International Council of Air Shows are also a very important part of this. So just wanted to show that my responsibility is really to coordinate between the four pillars that you see here. The light blue on the left, supply chain infrastructure and development, research and development and innovation are actually driven by the private sector, whereas the unleaded fuel evaluation and authorization pieces, as well as the regulation, policy, and programmatic activities, as you might imagine, are handled by the federal government. The FAA is really clear partner in all of this, specifically as it relates to authorizing supplemental type certificates for fuel and aircraft, depending on the model list for both engines and aircraft. And as well as testing of those fuels under the PAFI program, which is the Piston Alternative Fuels Initiative. A lot of that information is available on the FAA website. Currently, EAGLE is working on our website. We hope to go soft live here in the very near future, providing for basically resource information, et cetera. So really, again, our goal is to coordinate. My goal is to coordinate those four pillars that lead to lead-free skies. As I mentioned, the two pillars are industry driven on the left and the federal on the right. Our focus really is lead-free skies, and I'm going to just hold off right there. I think each of those pillars speak for themselves. And be happy to answer some questions, but I know Mr. DaCosta has got some really important slides to show as well. He produces the unleaded 94. It's out there on the market today, and he is working on an unleaded 100 octane fuel as well. So Mr. DaCosta, handing it over to you, sir.
Thank you, Robert. Welcome, everyone. Thanks for giving Swift Fuels the opportunity to share our thoughts. So as Robert said, Swift Fuels, we're the only producer and distributor of unleaded aviation gasoline across the United States. I'll explain a little bit more carefully what that means, but to understand our UL94, a 94 motor octane fuel, that fuel serves more than 70% of the U.S. piston fleet. It does not provide a full replacement for low lead. It provides a replacement only for those 70% of the fleet that are eligible to use it. And that brings about an issue. It has to be stored in a separate place from 100 low lead for airports that continue to operate using 100 low lead until such time as our 100 octane replacement comes along, which is coming in the months ahead. So to characterize UL 94, it's listed here on the chart. It says it's a proprietary formulation. We have FAA approvals of our STC, which is engines and airframes. There's a broader called an SAIB endorsement of all the aircraft, 70% of the fleet. There's an FAA registry basically of the different kinds of aircraft that can use the fuel. There's also, as Curt mentioned, an ASTM International Fuel Specification, D7547. That is a document which is basically reviewed, analyzed, and voted on by more than 150 members of the ASTM Fuels Task Force committee members that represent aviation fuels. It's a very important component to the overall thing because it's the industry's endorsement above and beyond the FAA's endorsement for the fact that the fuel has passed all of the hurdles that industry has, which is how it's manufactured, how it's handled, how it's produced, how it's delivered, and many, many other aspects that the industry cares about that may be beyond the purview of the FAA. The FAA's concern is engines and airframes. The industry's concern is fuel that navigates the entire of our supply chain, which includes equipment and things that go beyond just airplanes and engines. So it's a very important part to the whole equation. And of course, our fuel is also OEM endorsed. The engine makers like Continental, Lycoming, Rotax, and other engine makers endorse our fuel. The airframers, people like Textron Aviation that manages Beechcraft and Cessnas and a number of other major ones, even rotorcraft like Robinson Helicopter. Those are all OEMs who endorse our fuel, UL 94. So to bring a fuel to market, it's super important for airports like in Long Beach to understand the fuel must have three things. It must have the FAA certification, which comes in our case through the STC. It must have an ASTM International Fuel Specification, which is the endorsement of the industry. And it must have OEM endorsements. Those three things are what it takes to bring a fuel to market. Swift Fuels architected this plan. We did it without government mandate. We did it 7-8 years ago. It started selling in 2015. We managed it ever since. And we continue to manage what we believe will be the high octane replacement for 100 low lead, which we call 100R, which I'll talk about more in just a minute. So what makes UL 94 important? We wanted to set what we call the high water mark for an unleaded fuel. It's basically low lead without lead, but it operates clean. Exhaust emissions are very clean. You see here, but maybe an exaggeration of what can happen if you don't clean your cylinder head and spark plugs often enough. 300 hours on the left, that's lead caked on there. That's got to be basically carved off, as opposed to on the right, we run clean. You see the displacement on the piston. You see the cylinder head that's got the intake valve and the exhaust valve and where the spark plug sets. I mean, all these things are very important to the operation of the engine. And we run clean, no spark plug fouling, which is why our pilots that fly our fuel love it. People that fly regularly, flight schools that use it, they all save money by reducing the instances, the amount of times they have to go. Rather than going 50-hour oil change interval, they can move to a 100-hour oil change interval, and they don't have to change all their spark plugs every time they go. So it's a big source of reducing the cost of operating an aircraft. And that's what compels pilots to want to use it. We spent a lot of time, as you saw that picture of kind of the inner workings of the engine. There's a lot of emphasis placed on engine and detonation protection and the whole science of what is octane and what does it all mean. But there's a whole nother dimension, which is what I want to show you here. There's a whole nother dimension to the chemistry of the fuels. So the chemistry of the fuels must also be compatible with all of the elastomers and hoses and fuel diaphragms that are used in carbureted engines and fuel bladders that store fuel so it's not touching the metal wall, let's say, of a fuel tank. Tank sealants that keep the riveted tanks secure. These are chemicals, these are materials that come in direct contact. They're called fuel wetted. They come in contact with the fuel. Paints, epoxy, fabrics, metals. There's all sorts of different kinds of materials that come in contact with the fuel, whether intentionally or even accidentally. If you drip and spill fuel on your aircraft and your paint gets wet, you know, some of these chemicals can strip paint. If you look in the lower right-hand corner, you'll see some panels that came off of airplanes where drips of fuel dried, and then the chemicals inside the dried fuel basically strip the paint, strip the primer right off. Similarly, I don't have a picture of one, like a diaphragm, which is a piece of rubber that's moving back and forth, controlling your air to fuel ratio. If that gets flimsy or out of character, it can affect the ability of the airplane to control your air to fuel ratio. On the top right hand, that black thing, that's a bladder that contains fuel, and some of the chemicals can disturb the bladder, increase its tendency to leak, and or damage the the composition of it. And over a period of time, days, weeks, and even months, it can do some severe damage. So the material science is very important. This portion of the testing is more directly controlled by ASTM. The FAA has certain requirements, but they're minimum requirements. The ASTM is the one that really drives home all the specifics in this particular area, and they're very concerned about how these aspects of fuel be considered, which is why I want to emphasize again, 3 things it takes to have a fuel: an FAA certificate, an ASTM specification, and OEMs endorsing the fact that it works in their engines and airframes. Let's go to the next one. So everybody likes to share the logos of all your partners and participants, but I'm going to characterize it this way. So Swift, here we are at the top. We have a role to play in how we interact with the federal government. Who's the federal government? Well, the FAA certainly has a major role to play because they want to make sure the engines and the airframes meet the standard certification requirements, that your fuel meets the standard certification requirements of those engines and those airframes. And they have a legislated set of steps to follow, legislated by Congress. And so the FAA generally follows the minimum standards that are spelled out by Congress. But a lot of peculiarities and unique aspects must also be considered. So ASTM International, who I just spent a lot of time mentioning, they have other dimensions that they want to address, how the fuel is handled on a national and global scale. OSHA, it's more about fuel safety. If you're familiar with safety data sheets and how fuel gets handled and touched by people in the market, the DOT, the EPA are both on the right. So what are the truck limits of moving fuel down the highway? That's a DOT requirement. EPA is obviously looking at emissions for both air and land and water. So all the regulators in that tier, in that second tier there, are people we deal with on a day in, day out basis as part of Swift Fuels deploying unleaded fuel. Below that, you see Lycoming, Piper, Textron with Beecham and Cessna and Hawker, Continental Motors, Robinson. Those are a tier of OEMs. So we have to be constantly in communication with the OEMs because they have aspects of what they want tested that might be different than what the FAA wants and maybe different than what generally ASTM wants. Can you check the vibration of the propeller? Can you check what this engine does under this condition? They prescribe specifics to us, which we then go back and say, hey, FAA, do you agree with this? Do you not agree with this? So we're in a constant collaboration between the government regulators and the private industry, or the industry OEMs, in terms of what everybody wants. And it's challenging to get a collaborative answer. Then below that, you see many of the trade groups, the airports, the aviation businesses, GAMA's aviation manufacturers, which is engines and airframes, NATA is airports, API is the oil and gas industry, and many others. So there's a whole tier of trade associations whose members are in some dimension part of this overall equation. So they want to make sure they have a voice. So we work with them. We're a collaborator with Eagle. We're a collaborator with coalitions that exist on unleaded fuel. And on my screen, you can't see the bottom. There's a lower tier, which is the risk assurance companies, the insurance companies. I can't put fuel in the market unless the insurance companies provide me coverage. $50 million of product liability insurance, for example. And in order for them to be satisfied of that coverage and set the price for that coverage, they want to understand my recipe, my producibility, the expanse of my ability to sell the fuel, and all of that. So all these things are factored into what it takes to deliver a fuel in the marketplace. And we do all that. We do that today. We've been doing that since April of 2015. So over 7 years, we've been successful in deploying unleaded fuel with this sort of overarching formula of how we do it. So we got our eye set on what I call 100R. That's our 100 octane replacement fuel. It will be price competitive with low lead. We'll have it in the market without a formal government mandate from the FAA or the EPA. It's low toxicity. It does not have what are called aromatic amines, which are solvents that disturb materials in the engine. It doesn't have MMT, which can create more deposits in the engine and create other problems, we believe, for my firm. So our fuel is the cleanest burning exhaust. It has a 10% renewable component, so it has some value of sustainability. Its weight is equal to low lead, so there's no weight balance considerations for heavier fuels, for example, and it adheres to international industry standards on safety. Our formula is the lower left-hand thing. Our formula, one way of looking at the process we're going through is we achieve the minimum congressionally legislated requirements of the FAA. Those are called FARs, the Federal Aviation Regulations. We achieve those minimums, but we go beyond. We achieve the things that Eagle and PAFI are working on too as best practices. And we achieve ASTM international specifications, which are standards and test methods that are standards. And we achieve collaboration with the OEM. There is no one else that's doing that through the STC program today. And we think we're getting a broader, deeper, full coverage of what everybody wants in a collaborative style. And we're doing it in a big hurry to get the fuel out there as fast as we can. So that's how we're approaching our 100R fuel. And I'll cut it off there.
Thanks, Chris. So I'll take over from here. One of the biggest, first of all, NATA's mission is to empower aviation businesses to be safe and successful. And one of our biggest concerns as we transition to an unleaded drop-in replacement, we have that target goal of 2030, but what's going to happen between now and then, especially when you have the potential for 2 grades of avgas on a field, which now makes for 3 grades of aviation fuel at an airport. Our biggest concern at this point is the risk for misfueling. We've been the leaders in preventing misfueling for decades. We recently just updated and revised our free misfueling prevention training available to everybody at preventmisfueling.com to address the new risks that come with an unleaded avgas product on the field, especially until there's that 100 drop-in replacement that meets the needs of the entire fleet. We've still got 30% of the fleet out there that can't use Chris's UL94, and we want to make sure that that fuel doesn't find its way into an aircraft. So if you guys are putting UL94 in addition to 100 low lead on your airports, a change management process is essential. Understand what that process looks like. How is the signage going to work? Make sure you update the placards. Make sure your staff and your team are trained, whether it's full serve or self-serve. One of the biggest concerns with UL94 as it relates to misfueling prevention is that there's no grade selectivity amongst avgas nozzles. I know that's something that the EI Operations Committee is looking into. That's the Energy Institute who sets the standards for fueling operations internationally. But you've got a jet duckbill nozzle or a J spout that won't fit into avgas airplanes. That round spout for avgas, it's the same whether you're talking 100 low lead or UL94. So these are the types of considerations that we want to highlight and we point to on our new prevent misfueling training, and that you should be bringing to your team and making your pilots aware of out there. There's so many different components to this whole transition process, as our panels laid out quite well up till this point. But from a safety standpoint, it's really understanding what does it take to make sure the right grade of fuel makes its way to an aircraft every time. It's not a difficult task, but it's one that unfortunately our industry has gotten wrong with some pretty catastrophic consequences over the, in previous years. And now we just add this additional hazard, which provides for increased risk of misfueling across the board. So making sure your teams are up to date and trained on what it takes to prevent misfueling from occurring is absolutely critical as we transition, and we're in this transitionary phase until we have that drop-in replacement like our panel has mentioned. Curt, I want to turn it back over to you. Do we have any questions yet?
We do, but before we get to the live questions, there's a few that I'd like to ask the panel here. And there's a lot of press that's out in the publications relative to this process, and certain communities in the country are certainly under more pressure than other communities relative to the impact of lead in its communities. And certainly as an industry, we all support removing that lead in a way that's rational. And we have to follow the regulatory process that you've kind of heard about here through Robert and Chris. But maybe for Chris or Robert, the fuels that are being tested, and there are 4 in the programs being tested, Swift and GAMI and Lyndell, Phillips, and the other products that are out there. They're all going through their respective testing, but isn't it true that they're being tested against 100 low lead versus being tested against each other? And maybe Robert, for you, what's your thought about that? Is that something Eagle's going to have to address and the industry is going to have to address? Because ultimately that could mean that we have 4 different products that aren't necessarily, in the word that's out there, is fungible with each other. You're muted.
Thanks, Curt. I think it's a really important question. I'll want to hear Chris's opinions on this as well. Obviously, fungibility is going to be a pretty critical piece. Being able to mix different types of fuels, as Chris mentioned, they don't use MMTs, manganese, or some of the other products that replace the lead. And so when you start to use one, fuel that does use manganese and another that uses ethers, for example, as replacements, how does that work with some of these other fuels out there? We already have G100 UL out there that GAMI produced. They received their STC in 2022 in September. They're currently doing some flight demonstrations with that fuel because the OEMs, I think, have not had much of visibility to that fuel. So rollout has been very slow at this point in getting it out to market. I think getting the ASTM standard 7547D 7547 is really critical to that process as well. Again, I don't know if that fuel meets that standard. It also went through the STC process, just like Swift's fuel is going through that process. So I think fungibility, literally replacing one product with another like product is going to be pretty critical, lest we end up with 4 different types of things. Your assumption when you're putting gas in your car, whether you're using Shell oil or Conoco or anyone else, you want to be able to use a similar formulated standard, and I think that's where the ASTM becomes really critical. Chris, I'm sure you have some opinions on this as well.
Well, the way Curt framed the question, it's really a loaded question. So I will speak strategically for everyone's benefit. I'm the CEO of Swift Fuels. I've been in this role since Swift Fuels formed, and I've described a little bit of our history. I'm an engineer. I run a research and development company. I employ pilots. I employ chemical, PhD chemists, and a variety of other specialities in terms of what our skill sets. We have a lot of oil and gas and chemical and chemistry experience. So let me just say, I do not envision a day when there are 4, let's say, replacements to low lead that are active in the market, period. It's too complicated. You cannot bifurcate or trifurcate or whatever the word is, quadruplicate the market. You just can't do it. It's not big enough. Curt explained in the beginning that the actual volume of fuel is just not that much. And there's not enough tanks or combinations of tanks that are going to become viable. Why? Because the quote unquote side effects of a given fuel vary. How one chemistry works is different than how another chemistry works. It's not to say that you can't mix them up. It's just you're not sure what effects they're all going to have unless you position all the aircraft against the lowest common denominator, which means if you have to fix an aircraft or change a bladder or change a hose or change an elastomer or change an engine, you'll have to do those set of changes on every single aircraft in order to accommodate the lowest common denominator of all. And so I do not envision that happening. I'm sorry, I just don't. So it's going to become a systematic implementation over time. It's going to have to be done carefully. Everybody's going to try to manage misfueling like we are, like NATA is, and it's going to have to be careful. And I do believe, Robert didn't say it so directly, but I do believe that there is a role for Eagle in terms of how the multi-fuel scenarios could evolve with time, because Eagle's got a 7-year timeline or 8-year timeline on its books. So there could come a day when that role expands to include the fungibility of multiple fuels over time. But from my standpoint, we sell an STC for a reason. It gives us a very direct dialogue with pilots. They have direct contact with Swift Fuels. Their airplane is placarded. In some cases, their engine is placarded. They know what the pilot knows what he or she is responsible for. They are instructed on safety. Then, of course, the industry documentation, like what you see on this slide from NATA, further reinforces that with the fuel handlers, and everybody knows their job. There was a day when there were multiple fuels 10, 20, 50, 25 years ago. Multiple fuels is not a new concept like at a gas station, but people just have to know what their individual responsibilities are. The pilot is the commander of the ship, and he has to know what his ship is capable of and what he needs to do to buy it. It takes attention, and we want pilots in the air that take attention, that have that attention about what they're supposed to do.
Right. And for the
Go ahead,
for the
Steve.
pilots in the audience, one of the things that's come up in the past is just in the importance of verifying fuel orders, right? You used to be able to walk into an FBO and you'd say, top it off with avgas. Well, you only had one option, and that was good enough. But now confirming that fuel grade in the fuel order each and every time becomes absolutely essential for the pilot to confirm UL 94 or 100 low lead or whatever we ultimately end up with, hopefully less than 8 years from now. Chris, you mentioned that it's highly unlikely that we're going to have 4 formulations out there.
Yeah.
And we all know how important that the ASTM specification is to this. Is it likely we're going to see only one ASTM specification? And how do we get there? Does ASTM set that spec and then the fuel manufacturer refiners meet it? Or are they working with the fuel refiners to develop a spec and the market will determine which one is most feasible?
The fuel provider petitions for the spec. The fuel provider brings it to the audience of ASTM, and I mentioned that it's like the fuel representatives from the oil and gas industry, the OEMs, the distribution industry, and a bunch of other industries all sitting in a big room, and the fuel provider brings this spec forward and says, my spec has A, B, C, D, E, F, G, and you go down the list and they say, well, how did you test A? How did you test B? How did you test C? And you explain it all to them. And then they say, well, have you thought about this? Have you thought about that? And you go through this very rigorous review. Sometimes it can take months, sometimes it can take years of review. But the fuel provider voluntarily brings it forward to get the spec because he wants the industry to back the spec. Once the spec has been backed by ASTM, it's the basis for what gets tested by FAA.
Right.
Let me say that again. Once the spec has been approved, that's the fuel you take to FAA for getting the certification of that fuel. So if you choose to, let's say, ignore ASTM and you go your own route with whatever you want with FAA, and the industry hasn't backed it, then you're running a gigantic risk that the ASTM is going to back something different or may not back, the formula that you believe is the winner. So you have to kind of work in tandem. We're working with ASTM. We have a full task force. We've had one for several years. That's how we got UL 94 approved. We have a strong relationship with the whole of ASTM. Not everyone has that. Not everyone has that. So be careful.
Chris, let me say again, there's four folks in the process, right? And they're not all following the same steps, but they are following the FAA's guidelines in this, but they're not necessarily required at this point to go to an ASTM standard or in the engine manufacturers. And the reason I'm saying this is because there's a lot of press out there, and I think that the industry and the folks on this webinar and others need to understand that, for instance, GAMI, who got their STC, are currently going through you know, the process with their fuel in the industry, where they're doing demonstration flights with the engine manufacturers. That's another leg in their stool. So, you know, it's important to realize the FAA's STC is the minimum standards. That's one step. There's other legs that have to be met, and that's not always clear when folks are reading about this. You know, why isn't this product out in the market today? We understand it's approved by the FAA, and these are the reasons why it's not. So there's a few questions I want to get to. I'm going to let Robert, you want to answer that first one. Let me read it. Is Swift 100R participating in the Eagle initiative to receive a fleet-wide authorization to negate the need for STC? If not, it may be difficult to persuade pilots to use 100R if they need an STC, knowing that in the next few years, Eagle will produce drop-in, or there will be a drop-in replacement without the need for an STC. Robert, can you start that? And then Chris, you might have a thought about it.
Yeah, thank you, Curt. Good question. First of all, obviously, Swift they were actually in the PAFI program, and then left it to go through the STC process, which is a little more proprietary for one. It does require at the end of the day to obtain a supplemental type certificate. There's a cost involved not only to obtain the certificate, but there's a $100 charge for an ANI A&P to sign off on that as well. So the question relates to, you know, if at some point there will be fleet authorization for an unleaded 100 octane fuel. I keep wanting to say 100 low lead. I mean, when you've been doing that for I don't know how many decades, it becomes part of your vocabulary. So my apologies for that. So, but the bottom line is, as Chris indicated, he is going through some of those gates, if you will, that the PAFI program has established. Those really deal with OEM established standards. They want to have some visibility to how these fuels work. The STC is somewhat limited in that regard. Currently Eagle is working with the PAFI program to see if we can bring in the STC approved fuels into the PAFI process on an accelerated basis, so that we can again check against those OEM established standards as part of the PAFI process. So yeah, and I think there's still the question as to you know, whether we will have that a single drop-in replacement. We just talked about that. So, but it's a valid question. But at the end of the day, I think we probably will see fleet-wide authorization of a fuel, whether that has gone through the STC process or through the PAFI process. Chris?
Once again, challenging question the way it's framed. So can you back up one slide, please? Or maybe it's two slides. Right there, right there. So why is Swift going STC, and what is the role of Eagle as far as Swift is concerned? So Swift intends to continue the STC program, and when we get a particular critical mass of aircraft flying with our STC, we're going to enter the ramp of Eagle in order to get the back-end fleet-wide approval. That's what we're going to do. So there comes a point where there is a runway, an entryway into Eagle for Swift, but we want to do it after our STC program is well established. Robert is correct that Swift Fuels was part of the earlier PAFI program from 2014 to 2018. So we spent 5 years in the earlier program. I don't know any one of the current contenders that did that. None of them did that. Only Swift did that. So what Swift did in the third line from the bottom on the left says, enhanced PAFI best practices. We took what we learned from PAFI and all the conversations of the current Eagle program that we believe are relevant to us, and we're trying to accommodate those in our STC program. So it's like minimum FARs, minimum congressionally legislated requirements for the FARs, plus the best of PAFI in our STC program. So it's like we've sprinkled the secret sauce into our program for the STC to make sure we accommodate those things that we believe are going to be critical from a PAFI perspective, which will only accelerate when we come into the PAFI program later on, we'll already qualify for everything because we did everything that we knew was going to be critical to get done in our program. That's the way we're approaching this.
Chris, as a segue in there, for another question is, can you speak about how the ramp up will happen for R100? You know, let's assume after you get the approvals necessary, maybe the timing for that, but are you going to license the rights? Or, you know, how will the refineries participate? You know, obviously getting the availability throughout the industry and at airports is a concern. Can you talk about that a little bit?
Yes, it's a multi-layered question. So the first issue is, where will our fuel go when it's ready to be bought? So we have, I'll give you an example since we're talking California. We have 9 FBOs in California today that buy UL 94. And there's going to come a point when we're going to deliver 100R instead. So we're going to deliver 100R to those standalone tanks that those airports have set up for currently for 94. Those will become 100R tanks. Why? Because when the new fuel comes out, you can't co-blend it with low lead without confusing the market. You have to put your Kool-Aid into a container when people say, oh, I know what the new Kool-Aid tastes like. My airplane likes it. It works great. They have to taste the fuel pure, not mixed, not in a cocktail. So our rollout plan is to have a special set of tanks, which are going to be the ones the 94 tanks are in today. Those tanks are going to become the 100R tanks. And then with time, we're going to work on how the process of commingling that with the low lead tanks will occur. That'll take about 12 months, 18 months maybe. And that'll happen in a very orchestrated fashion once people's familiarity and concern. Now, you asked about how do we make it. So we make the fuel and we hand it basically to distributors. So people like World Fuel, AdFuel, Epic, Titan, the big fuel distributors are still going to be the fuel distributors. It's still going to go through them. We do that today with 94. We work with the same fuel distributors today that are in everybody's airports. So that part won't be different. The part will be upstream of that, where the things get put together. That will change, whether it's Exxon or Shell or BP or Chevron or whoever does it. We'll coordinate how that gets done in order to pass it to the fuel distributors, and the airports will see no difference. It'll be what's been done before.
So in a sense, the fuel refineries, if you will, are going to use the recipe and refine the recipe, and then you're going to use the fuel distribution network to distribute it.
Yes.
Correct? Right?
Yes, more or less that's correct.
Okay. Another question for you, Chris, is 100 are going to be color coded?
So the color is entirely a decision of ASTM International. So ASTM International, we're co-task force leaders with BP, the oil company BP. Swift Fuels and BP co-chair the Colors, Markings, and Dyes Committee for aviation gasoline on a global scale. So the first thing we did 3.5 years ago is we set out to kill or to terminate or to cease the operation of colors which were no longer used but still on specs. So I think we eliminated 9 colors of fuel, or in the process of getting that done on a global scale, to make those colors available for new fuels. And then the question is, well, which colors are best blendable to send a signal if you've misfueled? So we all know low lead is blue and there's other colors that are available, but we're trying to manage how the combination of colors can trigger a pilot to know he's created a problem. So that decision is happening by the task force. And some of those colors are being divvied up even now to the contenders with the major fuels and so forth, including 94, by the way. Our color of 94 is water white transparent, but it was only because ASTM never assigned us one. We petitioned, but we never got, because of what I just described over the last 3.5 years. It's been a change was required to be able to get in a position to use colors. Anyway, but that's all happening. So that's one of the things about industry collaboration and ASTM people may just take for granted or not realize, but it's part of what it takes to keep the fuels safe in the marketplace.
Chris, what's your timing for 100R through the process to get the STC approval?
We think we'll have the first commercially available version of that this year, 2023. We can't be working faster than we're working, but every time we move down a path, whether it's the EPA or the FAA or someone else says, hey, wait a second, I think you want to do this, look at that. So we're trying to accommodate everybody's desire to communicate with us. But my intention is to roll out 100R before the end of the calendar year and then begin an expansion program from there. So, knock on wood, I'm trying my hardest to make it all happen. And I can't do that without an FAA certificate, an ASTM spec, and OEM endorsements of my fuel. So if you want to know what I'm working on, there they are, those three things. Certification of my fuel with FAA, ASTM specification, and OEM endorsements of my fuel.
So let me add a little bit. Go ahead, Robert.
Yeah, I just wanted to jump in on the question of distribution, because Chris talked a little bit about the refiners and the distributors, but at the end of the day, the FBOs and airports specifically being able to handle that, and especially making that initial transition to take care of the 68% that can handle 94 UL, the 32% that absolutely require 100 octane fuel, are obviously waiting for 100 unleaded fuel, but they also consume between 70 and 75% of the total fuel consumption of the 160 to 180 million gallons. So you just simply do the math, and that's going to be an issue for the airports. Now, do they make that initial transition? We are very concerned about communities eliminating 100 low lead already, while they're immediately making that 94 UL available, which is great. But the problem is that there's 32% of the aircraft that cannot use that 94 at this time. So it's a transition for some of the smaller airports not being able to afford, for example, 2 tanks, 2 trucks, 2 methods of getting that into wing. That's going to be critical. I know my former airport, Centennial Airport, one of the FBOs is already switching out to have at least 1 tank available. And I'm sure, Chris, you are going to get a call from them. And they consume a lot of unleaded fuel. We've got 4 very large flight schools there, most of which are capable of taking those fuels. When you consider that the total consumption by automobiles in the United States equates to 4 days of fuel consumption by the aviation industry, you understand that this is an economic problem as well. And being able to generate millions of gallons has a cost to that. Chris made it very clear, trying to make sure that their fuel is within that price range of 100 low lead. I think that's critical. Just from price elasticity point of view, a lot of folks will not fly if fuel is on $10 a gallon, and I can't really talk about price here for antitrust purposes, but if that happens, that becomes a real problem as well. So it's an economic issue. We're actually looking at the possibility of maybe doing some floor planning, covering those costs to the manufacturers to make it more affordable, so we can actually start producing very large quantities. And I won't ask Chris what his current capacity is, but I think that's a critical piece to availability in the long run.
We have 400,000 or 500,000 gallons of capacity at our fuel facility here where I'm officed, and we have an additional fleet of rail cars that move fuel back and forth all over. So, I mean, we're set up to run. I've been in the oil and gas industry my entire career. I'm not a pilot. I'm an oil and gas guy. I'm a fuels guy. And I think we take this all very seriously. We follow the regulations very strictly. So, I just can't emphasize this is serious business to Swift Fuels.
Yep, Chris, you're young enough. There's 4 flight schools at Centennial. We have hope you're going to get that pilot certificate. Robert, you made some really good points about the percentages, and I'd just like to add a little nuance, because I think, again, folks on this call in certain communities are having different pressures. I know there's certain areas of the country where they're not feeling the pressure of communities on the leaded issue, as opposed in many of the metropolitan or urban areas. And so, as you said, 30+% of the fleet is burning 80% of the volume. And so that's a nuance that needs to be recognized. But I think where airports can do the evaluation, what I like to recommend to airports to do, and I've been able to assist a few airports big congrats to Santa Monica Stelios that's on the call today, but being the first to bring it to Southern California with Chris's help. I think that every airport needs to do their own really evaluation of their fleet. I've seen an airport where they study the fleet of piston aircraft at that airport, and possibly 80+% of the piston fleet can use the current UL 94. So when we talk about the fleet nationally of 68% and the balance of 32%, each airport's got a different percentage of that fleet. And so if you're in an airport where there's significant pressure on the community and you want to get ahead of the game for the final drop in replacement, and you have 80% of your piston powered fleet can possibly burn the current product, then you should be looking at ways to put in tanks or looking at ways to incentivize your FBOs. Or in certain airports are doing that. They're looking at various programs to be able to bring that product to market. And that's an important communication that has to happen in these communities so that the elected leaders understand the long-term process, the regulatory pressures, the complexities that you and Chris talked about. So one thing I'd like you to talk about, Robert, if you can, or at least, validate for me is, we're seeing communities around the country that are looking at, I'll call it early bans on the product. We've seen that in Reed Hillview. There's currently a Part 16 complaint with AOPA, and the FAA are certainly getting a lot of pressure there. We know that other airports have been told that they can't ban the fuel because it might be a violation of their grant assurance. Can you just validate what the EPA's position is as they go through their rulemaking, and what's the next step after the EPA? It's got to come back to the FAA, correct?
Absolutely, and that's a really important piece. And a lot of folks ask the question, why 2030? Why reach this milestone at by the end of this decade? Obviously, the goal is to get there a lot sooner than that, because this is a critical health and safety issue, but principally a health issue. The safety piece relates to the aircraft operators. The health issue relates to the emissions that are caused by piston aircraft containing tetraethyl lead, and removing that. So in the automobile industry that was banned ultimately by 1992, GA has been working on this issue for quite some time. As you talked about, Curt, earlier, the blending is having the right mixture of components to achieve high octane, while at the same time not adding either a toxin or a carcinogen that's worse than lead. You obviously want to make sure that we don't contribute to something else in the process of replacing lead. So I think at the reason why we have this 2030 deadline it would give the aviation industry a little more time to come up with a solution, hopefully sooner than that. And as you heard from Chris, he hopes to have his unleaded fuel on the market by this year, or at least have the STC in hand and start production. But there's the statutory requirement as part of the Air Quality Act that the EPA has to act on. So once they make a determination on January 17th, they had a proposed proposed finding of endangerment related to leaded fuel in avgas. I anticipate that either by the middle or the end of this year that the proposed finding will be an actual finding, a positive finding of endangerment. That then triggers the regulatory piece that the FAA will have to address, and that is to set the standards as to how that transition actually takes place, between public hearings from on the EPA side as part of the statutory requirement, and then public hearings as part of the FAA side, and they have to look at a lot of different things: the economic impacts, the health impacts. How is this going to affect the 1.2 million employees in our industry? Is this an existential threat, or is this something that we can solve? So the answer is that regulatory process is going to take a number of years, and that kind of put us into the 2027, 28 timeframe, maybe with some additional challenges. Certainly, the industry is committed to remove lead completely by the end of this decade, by the end of 2030. So that's really where the ramp up also takes place. But as I read this morning, Washington State is apparently now considering implementing a phase out of leaded, the sale of 100 low lead fuel by 2026 at some airports, and all airports by 2030. In the case of Reed Hillview and some other airports, they've already basically said those airports need to no longer sell 100 low lead. That creates a real problem for the aircraft that are out there that still need the 100 low lead or a substitute, an acceptable substitute until then. So that's a challenge for the industry. It's a challenge for airports. It's a challenge for elected officials who are trying to answer to constituents. It's a real issue. EPA and CDC have had standards related to emissions, 50 micrograms per cubic meter over an 8-hour period. The CDC looks at the lead threshold of 3.5 micrograms per deciliter. So those standards ultimately, I think, are going to go to zero with this proposed endangerment finding going to a positive endangerment finding. So it's something that has to happen, and the industry is committed to that.
Robert, thank you for that. I know we're running out of time. For me, it really drives the question that we need to do this in a collaborative, structured, rational way on a national basis where, if we did this by community or state by state, the impacts that will have. I think that, the ask of folks in the room here is to speak to your legislators and to get them to provide the support needed for Chris and the other participants in the process to get the necessary resources they need to get through the testing process as fast as they can, so that we eliminate the fuel much sooner and get to a product to market much sooner than 2030. I think that's, I think in creating incentives to do that versus regulatory bans, to me, would be a more productive way of doing it. I think that education to the elected leaders on what it means in their communities and how we can make investments now for this transitionary period to bring the fuel in that's available today is important. Robert, Mr. Rodin, I saw your question. I think Robert Olislagers is going to answer it.
Yep.
Simply, the question was about distribution of fuel by tanker trucks. And Chris, I know you do deliver fuel by tanker truck. And so that is possible today. We're right on the 9 o'clock hour. If there was any other questions, please, throw it in the question and answer of the chat. It's been great to have, this panel together, and Steve, I want to talk to you about how we might be able to make it available to folks on our website.
Sure.
Or share it if we're able to do that.
Absolutely.
I think, Chris, I know you're extremely available. You've made yourself available to so many airports and resources. You've been a good friend to this process. Thank you for being here. And I think if there was folks on the room, we'll certainly, with your permission, make your contact information available.
If people, just real quick comment about how much fuel and everything. If people have hangared aircraft and you have like tail numbers or airframe, engine airframe combinations you want to send to us, we'll tell you how many of them are compatible with 94. If you have a flight school on your airport property, like many of the airports that have our fuel, if the flight schools are compatible with UL 94, they're giant consumers of fuel. And, there's over 600 and some odd flight schools around the country, and many of them are in the category of the 70% of the airplanes 70% of the aircraft that are FAA approved for our fuel. So don't underestimate the impact to a flight school that this fuel, our UL 94 product, could have.
And Curt, I wanted to point our audience to the chat section. There's a couple of really great resources that we've made available through our NATA GA Fuels Handling Subcommittee. There's one in there called the UL Avgas Fact Sheet, or Unleaded Avgas Fact Sheet, that points to kind of clearing up some of those misconceptions you've seen out there in the press that you alluded to earlier. And then also a white paper we put together, Unleaded Avgas Conversion Considerations, some of the things that you also touched on, understanding who your base tenants are, what the market is for it, how to transition a tank, communicating with your fuel supplier. all really, really good points that our committee's put together. And Chris, you even helped with some input on that transition paper. We appreciate your help with that.
Absolutely.
Well, on behalf of Robert and Chris and Steve, many thanks to those that joined us today, and you guys, thanks for being here and taking an hour of your time to answer these questions. Very good dialogue.
Thank you, Curt. I also put my
Thank you, Curt.
email address up there, info@flyeagle.org. If anyone has any questions, info@flyeagle.org, and I'll be happy to answer.
Great.
Thank you so much for your time.
All right, take care.
Thanks, everybody. Bye-bye.
Thanks, everybody. Bye now.